This is Algebra 2 with Trig. We're working with Unit 2.5. We're going to call this C. We're still factoring and solving. In this case, we're practicing expanding our polynomials. So here's what the first row is talking about, that when we're factoring, we have the difference of two squares. If you can take the square root of the first term and you can take the square root of the second term, I typically like to write it in there. If you can take the square root of that first term and if you can take the square root of the second term, remember it has to be the difference. Then it's going to be x minus 2 and x plus 2. The rule is here. If you have two squares and you're taking the difference of them, then you can write it as a minus b and a plus b. So this one's a little bit different. This is a perfect square trinomial. The rule for a perfect square trinomial is to square the first term. 2 times AB, multiply the two together, times 2, plus b squared. It's different than the sum and difference of two cubes. We'll talk about that later. So if this is what we have in factored form, if we were going to write it in expanded form, you could separate it and write it as two different binomials and FOIL it together, or you can use the special rule. You can write it as y squared plus 2 times 3y, which gives you 6y, plus 9. Might be a little bit quicker by using the shortcut method for you to set up what the expanded form is, or you could write it as two different binomials and FOIL it together. Here we're still working with a perfect square trinomial. Notice that this time we have a minus, so your sign is going to change. You're going to be a squared minus 2ab plus b squared. So what you want to find out is, can you take the square root of 4h squared? And yes, you can. That's 2h. Can you take the square root of 9? Of course you can. Is the middle term 2 times 2h times 3? 4, 2 and 2 is 4, times 3 is 12. So yes, it is. Check. So you know that you're going to have 2h, you're going to have 3, and for you to get a negative 12, the middle term has to be negative. Down here, we're at the sum of two squares. The sum of two squares has a rule that if we can take the cubed root of the first term and cubed root of the second term, then we can put them in as a binomial. We square the first term, change the sign, multiply the two together, and square the b. With the acronym SOAP, same is the sign, opposite is the sign, and always positive is the sign. So to remember your signs, you can think of the word SOAP, same, opposite, always positive, if that helps. So down here, we think about the cubed root of x cubed. We get x. We think about the cubed root of 125, and of course we get 5. So yes, you can take the cube root of both of those. So we can write this as x plus 5, square the first term, change the sign, multiply the two together, and square the last term. Very similarly, this is the difference of two cubes. The difference of two cubes is still going to be a minus b with square the first term plus ab plus b squared. We have the opposite sign. Same, opposite, always positive. So you first want to identify, can you take the cubed root of the first term? If it's cubed, sure you can take the cubed root of it. So we have m and n as a cubed root. So it's going to be m minus n, m squared, plus mn plus n squared. Now we get a little bit more complicated. We are cubing a binomial. That's not the same thing we just did. Before, we were cubing a term minus cubing the other term. This is cubing the whole binomial. So one way you could write it is to say 2x plus 1 in parentheses, 2x plus 1 in parentheses, 2x plus 1 in parentheses, and FOIL it all together. Totally worked. But to let you know, there's also a pattern. Pattern's a little tough to identify, but it is a pattern nonetheless. 1, 3, 3, 1. Remember, that comes from the third row of Pascal's triangle. We've talked about Pascal's triangle before as 1, 1, 1, 1, 2, 1, and 1, 3, 3, 1. You always add the two previous numbers down, so that's what gave us the 3, and we start and end with 1 every time. So that's the third row because we're doing a cubed root. Then you take your a term and you multiply it to every one of those values. We're going to take our exponent, because we know this is going to be a cubed, and then a squared, a to the first power, a to the last power, or 0 power. The last one is to the 0 power. Then we're going to multiply it by b, by this b term. This first one is not going to be a 3, but we're going to go backwards. So we're going to go 0, then 1, then 2, then 3. So that is your pattern of what we're doing. So when we take this, our a term is 2x and our b term is 1. So we're going to use 1, 3, 3, 1. So we'll take 2x and multiply it to each one of these. Now think about what the exponents are going to be. We're going to put a 3 there. We're going to put a 2, 1, and 0. Then we're going to put our b term here. Now, when it's a 1, it's pretty much irrelevant, but we'll put it in there anyway. With our pluses in between each one. So that's our pattern. You just created it by the pattern. The A term being cubed and squared into the first power. The B term, this would really, I guess I should put my exponents of 0, 1, 2, and 3 on that. When it's 1, it's irrelevant. It's just 1 times 1 times 1, which is still 1. So 2 cubed is going to be 8. X cubed is going to be x cubed. 2 squared is 4. 4 times 3 gives you 12. 12x squared. 2 to the first power times 3 gives you 6. Times 1 gives you 6. 6x. And then 1. Anything to the 0 power is 1. And when 1 is cubed, it's still 1. So that was pretty nice. We're going to have the same idea when we come down here and work with the negative. We'll still start out with 1, 3, 3, and 1. We'll still put our A term next to it with the descending order of exponent. Then we're going to put our B term next to that, which in this case we're going to call negative B, negative B, negative B, and negative B. That would be to the 0 power, to the first power, to the second power, to the third power. And put pluses, just like before, in between. So that's your pattern of what you're going to have. So we come over here, and we notice that our A term is going to be x, and our B term is going to be negative y. So 1, 3, 3, 1. We do x, cube it, square it, first power, 0 power. If this seems confusing, just think about what we just did. 1, 3, 3, 1. And there we put x's with a descending exponent. Now what are we going to do? We're going to put the y in here. With an increasing exponent. Notice that the sum of the exponents, 3 plus 0, that's 3. 2 plus 1, that's 3. 1 plus 2, that's 3. 0 plus 3, that's 3. And we put pluses in between each one. Notice there is not a plus in between the x and the y. It's just in between each group. So x cubed times 1, and anything to the 0 power is 1, so that's just x cubed. Watch your sign here, because this is negative y to the first power. So you're going to get that negative. We might as well move that negative to the front. It's not a minus y, it's a negative 3x squared y. So you could call that minus 3x squared y, but it's not a minus y here. when you square your negative, you're going to get a positive, so you'll be keeping your positive sign. 3xy squared. And then 1 times something cubed. A negative being cubed is going to be a negative y cubed. So we did it. So that's one method. You could work it out if you would like to FOIL that all together. What that would look like, if you would like to say x minus y cubed, you could say x minus y, x minus y, x minus y. You cannot just distribute, of course, that through. So we'll get x squared minus y, or x negative y, and again x negative y, which is 2xy, plus y squared. That's that pattern we had learned before from squaring a binomial. And we have x minus y. Then we're going to get x cubed, negative 2x squared y, plus y squared times x. I guess I could have put the x first, but it doesn't matter. Here, we have a negative yx squared, or a negative x squared y, all right, getting a little confused on what's happening here, but no, maybe it's working out just fine. Then we have negative y times this makes a positive. And then we get, did I say that wrong? A negative and a negative makes a positive. 2xy squared. And then a negative y cubed. Woo! So we have our x cubed. We have 2 of them here and 1 of them here. That's a total of 3 of them. We have 1 of them here and 2 of them here. That gives us 3 of them. And then we have that, which should be the same thing we got there. So either way you want to do it, you'll get the same answer. When it's a cube, it might be faster to do it this FOIL way. If it's the pattern, it's a good thing to kind of get used to and work with. All right, with some quadratics, we don't have a special rule for factoring to the 4th power. No need to think about anything new. You're just going to treat it like a normal quadratic. So your normal quadratic, we're looking, if you think about this as a guess and check format, you're looking for 2 things that are going to multiply to give you 2. Well, that's only 2 and 1. To give you x to the 4th, that's x squared and x squared. That's how you get 2x to the 4th. Now you need 2 numbers that multiply to give you 28. Now that can be 7 and 4, that can be 2 and 14, that could even be 1 and 28. We've got to get down to negative 1. So if you say 2 times 14 and 1, that doesn't help. 2 times 7 and 4, 14 and 4 would give you 10. That didn't work. Oh, how about if we did 2 times 4, that's 8. and then put your 7 over here, 8 and 7. We need it to be a negative 8 and a positive 7 to be sure we get a negative 1. There it is. We factored it. That's called guess and check. If you don't like those special numbers going through your head, then you should make your chart and factor this by grouping. This is 2x squared plus 7, x minus 2, x plus 2, because that's still the difference of two squares. A last one. If we have 4 terms, to this point, the only thing that we know what to do is to factor by grouping. So with factor by grouping, we're going to circle the first group, we're going to circle the second group. Put circles, don't use parentheses. Factor out what you can. That's going to be an a squared, which is going to leave you an a plus a 2, minus, factor out what you can, leaves you an a plus a 2, because negative 9 times positive 2 gives you negative 18. This is a squared minus 9, a plus 2. And don't forget, you need to factor completely. This is the difference of two squares. So a plus 3, a minus 3, and don't forget your a plus 2. Nice job.